Welcome to a sim code, ready to break down some code, and maybe a few walls while we're at it. Hit that subscribe button, and let's create something amazing. You're not going to want to miss what's coming next. Binary cross-entropy, BC, is a loss function commonly used in binary classification tasks where the goal is to predict one of two possible outcomes, for example, 0 or 1. Importing the number.py library, which is used for numerical operations and array handling. Binary cross-entropy loss function. Y_true, actual labels, ground truth. This should be a 1D array of zeros and ones, representing the true binary labels. Y_pred, predicted probabilities, output of the model. This should be a 1D array of probabilities between 0 and 1, output of a sigmoid function or any other model that predicts probabilities. First, we need to prevent any possible issues with log 0 by clipping the predicted probabilities. We use the np.clip function, which is a number.py function that limits the values of an array to a specific range. This is done to ensure that the values of y_pred do not become exactly 0 or 1. As log 0 or log 1 to 0 log 1 can lead to numerical issues, infinity or undefined results. A small constant value to prevent log 0 or log 1 from causing errors. np.clip takes an array and clips values below epsilon to epsilon, and values above 1 epsilon to 1 epsilon. This ensures that y_pred values stay strictly between epsilon and 1 epsilon. This is particularly useful when y_pred values come from a sigmoid activation function. Clipping values to avoid log 0 and log 1 errors. Now, let's calculate the binary cross-entropy, BC, loss using the formula. This formula is derived from information theory and measures the distance between two probability distributions. We are measuring how much the predicted probabilities differ from the actual ground truth labels. Here, we calculate the element-wise loss for each pair of y_true and y_pred. If y_true is 1, we calculate log y_pred. If y_true is 0, we calculate log 1 y_pred. np.log is a number.py function that computes the natural logarithm, log base e, of an array element-wise. Calculating the BC loss. To get the average loss across all samples, we use np.mean, which computes the arithmetic mean of the array. np.mean is a built-in number py function that calculates the average value of a number py array along the specified axis. In this case, it calculates the average loss across all data points samples. Example usage. Let's create some dummy data to simulate a case where we are classifying binary labels. y_true represents the actual labels 0 or 1, and y_pred represents the predicted probabilities for class 1. Actual labels ground truth. These are binary values 0 or 1. Number py array of size 5, binary values 0 or 1. Predicted probabilities for each sample, output from a model. These are continuous values between 0 and 1. Number py array of probabilities between 0 and 1. Now we call the binary_cross-entropy function with our sample data. Print the calculated binary cross-entropy loss. The loss value represents how well the model is performing. Now run our code. Hey, if you're into coding, or just getting started, don't forget to like this video and hit that subscribe button. It's super simple, but it really helps me keep the channel going and bring you even more fun coding tutorials. So, go ahead and click that button, and let's keep building our coding skills together.